Once again with our array of numbers, let's say we want to calculate the sum of all these numbers in this array. This would be similar to calculating the total cost of all the items in a shopping cart. So each numbers here could represent the price of an item in a shopping cart. Of course, we wouldn't have a negative number there, but you got the point. So here's a very simple algorithm for calculating the sum of all the numbers in this array. We start by declaring a variable called sum, and we initialize it to 0. Next, we loop over this array, get each element or each number and add it to sum. Something like this. For let n of numbers. Now we want to add n to sum. So we can write an expression like this. Sum equals sum plus n. Or a better way is to use the addition assignment operator. So we can exclude this second sum. So this is exactly like the statement we had before. And finally, we display sum on the console. So we get 5. Now there is a cleaner and more elegant way to write the same code using the reduce method in arrays. So all these arrays have this reduce method. And with this method, we can reduce all these elements in an array into a single value. That single value can be a number, it can be a string, it can be an object, it can be anything. In this example, we want to reduce all these elements into a single number. That is the sum of all the numbers in this array. So let's see how we can use the reduce method. This method takes a callback function with two parameters, accumulator and current value. So here I'm using an arrow function like this. This accumulator parameter here is exactly like this sum we have here. It's something that we initialize, and then this callback function is executed multiple times. Each time, this current value will be set to one element in this array. Okay? So in each call, we want to get this current value and add it to accumulator. So we simply return the sum of accumulator plus current value. Now, internally, this reduce method will get this result and store it in the accumulator. You will see that in a second. Now, one last thing we need to do here is to initialize this accumulator to 0. So as the second argument to the reduce method, we pass 0. Note that this reduce method has two arguments. The first argument is a callback function, and the second argument is the initial value for the accumulator. Finally, we get the result as a single value, in this case, sum. Now we don't need this code anymore. And finally, let's bring this console.log here. Save the changes. You can see we get the same result, 5. But let's see what exactly is happening here. So initially we set accumulator to 0. So I'm going to set a equals 0. In the first round, current value will be set to the first number. So c equals 1. Now we add this together. So we get 1, and a will be set to 1 after this callback function is executed. So as a result, a will be 1. Now in the second round, a is 1. Current value will be set to the second number in this array. So -1. Now once again, we add them together. So a will be 0 after the second call. Now the third call. So a is 0. The current value is going to be set to the third element in this array. So 2. And as a result, a will be 2. And finally, in the last call, we start with a set to 2. And current value will be 3. Okay? So the result will be 5. And that's why we saw 5 on the console. So essentially, with this reduce method, we start with an accumulator. Then we loop through this array and convert all these elements into a single value, which is in this case, accumulator, or the sum of all the numbers in this array. Now we can make this code even shorter. We can exclude the initialization of the accumulator, and with this, accumulator will be set to the first element. So let me show you what will happen. A will initially be set to 1, and current value will be set to -1. That is exactly like our second call here, right? So as a result, A will be set to 0. Now, in our second round, A will be 0, and current value will be 2. Because in the previous call, current value was here, so now we are here. So current value will be 2, and as a result, A will be 2. And finally, in the last call, A will be 2, and current value will be 3, the last element in this array. And once again, we get 5. So if we supply an initial value, we'll have one more call. If we don't, the first element in this array will be used as the initial value. So this is how the reduce method works. And finally, to make this code a little bit shorter, we can get rid of this return keyword because we have a single line and we are simply returning a value. So remove the return, the semicolon, and the curly braces, put everything on a single line like this. So with this single line of code, we reduce the numbers array, and this is how our reduction algorithm works. We simply get the current value and add it to our accumulator. This is far cleaner and more elegant than declaring a sum and then looping over this array, like let n of numbers and then add n to the sum. That's a very old way of writing code.